Hello and welcome to episode 75 of the HamCorp training manual. In this episode, we will set up our first 4 circuit assembly lines and automate them. After that, we will upgrade the basic plat line to LUV and refactor part of the chemicals building. We will also continue improving our infrastructure with new coil blocks to prepare to craft the first fusion reactor. As you just saw, I made 4 circuit assembly lines. I need to make 6 more, but I have some material issues, specifically platinum. I'm very low on platinum. But we can start with these 4 for explanation's sake. And I'm going to start with the 4 lowest tier circuits. So ULV, LV, MV, and HV. We're going to need a circuit imprint for each of these. And the circuit imprint is made with this crafting recipe using a sliced circuit. A sliced circuit you can get from a slicer or from a cutting factory set to slicing mode. I'm just going to make a slicer for now. And it needs to be in the clean room. You also need a slicer blade, and then you just put in the circuit that you want to make an imprint for, and it'll make a sliced circuit. And then once I have the circuit imprints, we can set up the circuit assembly lines. Here we are with our 4 assembly lines. I've already hooked them up to power, and I've also hooked them up to Applied Energistics. It's exactly the same setup as what you did previously for the assembly line. The only difference is you don't need an ME controller because there are less than 8 channels being used on the subnet. Don't forget to set the priorities of your storage buses in ascending order from the end to the start, so the start has the highest priority. On your 2 interfaces, the one on your main net needs to be set to blocking mode. Do not push crafting items if inventory contains items. And on the receiving dual interface of the subnet, you want to put in an advanced blocking card. Now we can imprint these circuit assembly lines. So I brought my circuit imprints here, and the way this works is you put in your circuit imprint and you turn on the machine, and that consumes the imprint. Now this circuit assembly line is forever imprinted with NAND chip array. So I can only ever make NAND chip arrays in this circuit assembly line. I'm going to do the same for the rest of my circuit assembly lines. And I'm also going to teach these wrap recipes to my assembler, because these are used in basically every single circuit recipe. And then I'm going to teach the circuit recipes themselves to this dual interface and name it also. And then we're done. Then I have circuits. Of course, these are only 4 circuit assembly lines. I want to make 10. So still quite a bit of work to do. One thing I forgot to mention, by the way, the circuit assembly line gets perfect overclocks, just like a large chemical reactor. So you can put in whatever voltage you want, and you don't lose any efficiency. It's still the same total EU cost per craft. By the way, I said before that I wanted 10 circuit assembly lines. I think I miscounted because I only need 9. But anyway, to make the next 5 circuit assembly lines to bring me up to a total of 9, I need a lot of platinum. I have so much platinum metallic powder dust, and it's not being processed fast enough because I don't have enough hydrochloric acid. On top of that, all of these machines are still at EV. In fact, all the machines at the plat line are, I think, at most IV, if that. I think they might even all just be EV. I don't even totally remember. But I've dug out a little space here. I'm going to pretty it up, but I'm going to put a Lapatronic supercapacitor in there. I'm going to slowly, in stages, rewire the whole plat line so that everything connects to this new buffer, because then I can upgrade everything to LUV. And also this fits into my grand plan of removing the cables from the maintenance tunnels. As for how to get more chlorine, I have to think about that a bit more. So as a quick band-aid solution for my chlorine problems, I noticed that I have a lot of sodalite that I haven't macerated. I also have stuff like malachite, I have tricalcium phosphate, I have apatite. All of these gems that, as far as I'm aware, have no real use in their gem form. They're just sitting in my storage. So I'm going to start crushing these and then electrolyzing the dusts. Obviously that's not infinite chlorine. It's going to get me a lot of chlorine. It's going to get me close to 10,000 buckets of chlorine from the sodalite alone. And that's a lot, but it's not infinite. So for an infinite chlorine solution, I'm probably going to do bees, but I'm trying to avoid it because I don't want to rely on bees too much because I think that's kind of boring. But if there really is no other comparable option, then so be it. For now, I really want to get those circuit assembly lines going. This circuit assembler is for quantum processors. It's a little bit longer than the other ones because I can't use the smallest recipe yet because it needs ZPM power and the circuit assembly line only accepts one energy hatch. So it needs to be a ZPM energy hatch. So I have to go with one of these, and I've gone with the top option because it's cheaper in terms of energy and also advanced capacitors and advanced transistors. And now for the next 4 circuit assembly lines. They're meant for these 4 circuits, the crystal tier of circuits. So the crystal processors, they do need crystal chips, which needs europium. And europium I get from fusion. Oh boy. So I guess the remaining 4 circuit assembly lines are going to have to wait. I mean, I guess I can construct them now, but I'm not going to get any use out of them for some time. But anyway, to get to fusion at all, I'm going to have to do some upgrades. I need Naquata alloy. This needs a Naquata tier heat capacity in my Vulcanus or blast furnace, and that means I need to make the Naquata coils, and that shouldn't be too difficult. Besides the coils, I'm going to go around the chemicals building and upgrade as many energy hatches as I can to LUV or at least IV, and I'm also going to upgrade the plat line energy hatches. I still haven't done that. I don't think it's going to be particularly interesting to watch, so who knows when I'll see you again. I have cleaned up my simple plat line. I haven't touched the rest of the plat line, but platinum itself, everything is now running at LUV. It is so fast. It's super fast. I'm very bottlenecked by my ammonia production, so I'm gonna go work on the chemicals now. But yeah, just thought I'd show you. I replaced all the single blocks with multis, and I just, yeah, now it's like a nice clean L shape instead of the weird bulge it used to have before. Also, the Naquata coils look pretty nice. I like it. It suits the, like the HamCorp black vibe that I'm going for. Here is another progress update. I started to redo my chemicals building. I've removed a lot of things, and I've moved a lot of things, clearly. Just mostly to try and consolidate all of these like dense cables that I have. I know I can use P2Ps, but I kind of like how it looks with these just giant cables going, and they're not that expensive for me anymore. And it's a real pain rewiring this, trying to swap it out for LUV cables. I'm trying to do the new setup in a way where it's easier for me to rewire it. For most of these, the single blocks are a little bit different, but for most of these, all I have to do is swap out the hatch here. Before, I had the cables hidden and I had to like dig underneath. It was a pain in the ass, so I will no longer be building like that. I managed to save a little bit of inert casing by wall sharing a bunch, and there's some logic to how these are arranged, just a little bit. These are all my acids. All of these are acids. I'm missing nitric acid because that's made so slowly it needs a quad, and that's all the way over there. This whole side of the building has not been migrated yet. I put a new Lapatronic supercapacitor here. This is like in the middle of the bridge of the chem building, like right here. And I also moved my travel anchor here. But yeah, the most important thing here that I wanted to talk about is that I removed my plastic polymerization completely. I've taught all of those recipes to my LCR because basically every craft happens in like a tick at this point. They're all LV recipes or MV recipes. So at LUV, everything happens very, very quickly. Especially because these are all chemical reactor recipes, so they overclock nicely as well. So I've got a list of things that I have removed from my chem building and just taught to my applied energetics system. I thought it might be interesting. So iron 3 chloride is gone. The silicon solar grade poly-SI loop is gone. Epoxide bars are gone. Epichlorohydrin is gone. Advanced glue, polyvinyl acetate, vinyl acetate, polyphenylene sulfide, sodium sulfide, dichlorobenzene, redstone. Redstone. This is not exactly redstone. So it's actually the recipe that centrifuged glowstone dust into gold and redstone. I really didn't need that anymore because gold, I have so much gold just from mining. And redstone I now generate using the blood sapling. So I really didn't need to be using my glowstone like that anymore. Anyway, also styrene butadiene rubber, which also means styrene, silicone rubber, polyethylene, polyvinyl chloride, and polytetrafluoroethylene. I think there are going to be other things in the future that I'm going to kind of deprecate, but for now, I think I'm just going to leave this as it is. A lot of these machines are still at IV or lower, but everything that's connected to the yellow or orange cables here are LUV, and that is the majority of things here. So still a work in progress, and I think it looks a lot more organized. Just made a nice big batch of Naquata coil blocks because I'm going to need Naquata alloy. And of course, blasting Naquata alloy dust needs Naquata coils. But I also need trinium. Remember how I said I was done with the Naquata line for now? Yeah, I'm not done with it. So the way you get trinium is from trinium sulfate. Pretty straightforward after you get trinium sulfate, but trinium sulfate comes from enriched Naquata oxide mixture dust. So from half a stack of Naquata oxide mixture dust, you get about a third of one enriched Naquata oxide mixture dust. So that is a pretty terrible rate, but I have a lot of it from mining, so that's pretty nice. Now processing this stuff is actually pretty straightforward because of how it links into the existing Naquata line that I have. So the enriched Naquata oxide mixture dust gets combined with a lot of sulfuric acid and P507 in an LCR, and we get enriched Naquata solution, trinium sulfate, Naquata oxide mixture dust, and waste liquid. The Naquata oxide mixture dust is our starting point for the NAC line, so that just goes back there. And the waste liquid is handled as part of the NAC line already, so I'm just going to send it there. Now the trinium sulfate gets combined with hydrogen in an LCR to get trinium dust and sulfuric acid. This is a tiny, tiny amount of trinium dust. If you think about how much enriched Naquata oxide mixture dust you get from regular Naquata oxide mixture dust. Very small. But yeah, so that's trinium. As for the enriched Naquata rich solution, we combine this with sodium hydroxide dust in an autoclave, and that gives us our P507 back, and it also gives us 51.2 concentrated enriched Naquata sludge dust. Just like before, I scaled everything up to one stack of enriched Naquata oxide mixture dust. Relatively straightforward, especially because the concentrated enriched Naquata sludge dust just goes back into the NAC line. That's a dust we've already seen. And I've looked closely at the three things that get looped back to the original NAC line. Luckily, there are no loops that break as a result of these three, so I can safely just send it back to the machine where they're processed right now. Pretty easy to set up. So we have our two LCRs and the autoclave, and this makes trinium as well as, well, stuff that goes back into the NAC line. I'm also going to go ahead and make one set of Naquata alloy coil blocks, because this EBF in the plat line, this Naquata coil block actually is not hot enough for a perfect overclock. I have like 4 perfect overclocks and 1 imperfect, so I may as well upgrade this to Naquata alloy coil blocks. It's so hard to say. And then that'll get me another perfect overclock. So just a little bit more efficient, and a use for these, I guess. These look almost the same. It's like a little bit darker, so it actually fits HamCorp a little bit better, I think. Very small difference. This episode has been a lot of just random upgrades around the base. Let's do one more. So my main material shortage at the moment is fluorine. I have no fluorine. And one nice way to get fluorine is from biotite dust, which you can get from centrifuging black granite. And black granite you can get from black stone lily. This gives you black granite. I don't have any black stone lily, and I need to set up a farm for that. Breeding up the black stone lily is also going to take a bit of time. So what I want to do instead for right now, while that happens, is I have 2.7 million stone dust just sitting in storage doing absolutely nothing. I'm going to centrifuge it and get biotite. I can't centrifuge all of it because I do need some for drilling fluid for my miners. So I think I'm going to keep 100k stone dust, and everything above that I'm just going to centrifuge. But I'm going to centrifuge that and get biotite dust, and then the biotite I can electrolyze to get fluorine along with other stuff. On top of that, I'm going to get all this other ore, including metal mixture dust, which is even more stuff that even has a little bit of titanium in it. And I checked the math for how much stone dust I have, and if I electrolyze 2.6 million stone dust, I'm going to get about 26 million buckets of fluorine. This is just about 400 stone dust for 4,000 fluorine, so it's like 1 to 10. Again, man, so rude. So that's going to give me like 26 million fluorine, which will last for quite a while. But don't worry, I will also work on the stone lily. And once I have the stone lily, I can start moving things from the farm into extreme industrial greenhouses. That will make everything at the farm go a lot faster. In fact, that could be useful because my blaze rods are not being generated that fast. Like, it's fast enough for now, but if the demand increases, this is not going to keep up. Okay, that was quicker than expected to set up. Basically, it's just a centrifuge. Because I have so much stone dust and because the centrifuge recipe is so slow, I decided it's better to just have a dedicated centrifuge for stone dust. so it's not interrupting my other dusts. Here I have my stocking input bus with stone dust, and I have a level emitter that outputs a redstone signal if I have more than 128,000 stone dust. And on the controller here, I have a machine controller set to enable with redstone. All of the dusts that we make are already kind of pre-programmed into these existing centrifuge and electrolyzer. So I'm done. And the fluorine should slowly start coming in. I'm still working on breeding up my crops, so it's going to be some time. Besides that, we're basically ready to start collecting the fusion blocks. So I'm going to do that. I've already taken a look at all of the different materials that go into the Fusion Control Computer Mark 1, as well as the Fusion Coil Block. The only new thing really is the superconducting coil block, and it just needs superconductor wire and molten trinium, so it's really not too bad. The trinium needs Naquata coils, but we have that already. Everything is ready. Thank you for watching this episode of the HamCorp Training Manual. In the next episode, we will continue progressing towards the crystal tier of circuits by setting up the fusion reactor to generate europium. After automating crystal tier circuits, we will fill up the rest of the storage drives with 256K storage cells for completeness sake. And then, potentially, we'll start working on Botania, Blood Magic, and Witchery, which has been long overdue. See you next time.